Hello everyone, thank you so much for joining us today. We have a prestigious panel here that will be discussing relevant threat detection and responses and the AI platform that is associated to build that environment for us. Allow me to introduce myself. I am work at Northrop Grumman. We do various different types of detection and product services to the Department of Defense.
Ryan Peters, Chief Data Scientist at BluVector. We built a platform that's focused on threat detection and threat hunting. So looking at both the pre-breach and post-breach detection capabilities, basically at a high level finding bad content and bad behavior that's on your network.
Good morning, my name is Mark Sherman. I'm one of the directors in CERT, which is the Cybersecurity program at the Software Engineering Institute. That's a research organization based in Carnegie Mellon University, which works a lot with the Department of Defense and the Department of Homeland Security. And my particular group focuses on how to use machine learning and artificial intelligence in cybersecurity.
Hi, Garfield Jones, the Associate Chief for Strategic Technology out of the Cybersecurity Infrastructure Security Agency. I can't believe I got that all out this morning, but it works. So yeah, my main focus is R&D for cybersecurity, looking at various aspects of threat hunting, vulnerability management, threat intelligence, and trying to get our R&D developments into operational aspects so that we can help this as a mission. Thank you.
So what we're going to do today, ask certain set of questions from the panel and some of the other panel persons here that might be adding in, and then at the end we'll open up the forum for some Q&A from the distinguished persons here. So the first question I have for you is automation of authentication and allowances for response and detection. What are the relevant key ingredients of this situation?
So when you're trying to, so the first step is you need to sort of scope out what problem you're trying to solve. You know, what are the threats that you want to prioritize? So this involves defining what your operational outcomes are going to be, what your measures of success are, and really thinking from the beginning about the user workflow. So where does the automation part of it end and the user decision making, if you will, begin? So once you figured out what you actually want to solve, then you get more into the nitty-gritty of the data science side of things. And you know, the first question I pose is, you know, do you actually need to use AI and ML to solve this problem? You know, a lot of times we're looking at, you know, I want to add ML to my security stack. But you really need to think first about the problem you want to solve. You know, if you decide that ML is the right approach, then it's looking at the you know, the inputs and the features. So with network security in particular, sometimes it's hard to get really good labeled data sets. In some cases, you may need to get some synthetic data, particularly around anomaly detection. For your feature engineering, it's really important that your data science team is in contact with cybersecurity experts, so you really understand the underlying domain. And then obviously choosing the right you know, machine learning algorithm for the problem. And so, you know, as you deploy it and you get into this you know, feedback loop and you get into a certain level of accuracy that you're comfortable deploying it, you know, it's really about you know, how do you build trust in that model? You know, because if you build a really cool detection capability and the SOC team's not going to use it, well, you know, what's the value of, you know, investing a lot of time?
Okay, fantastic. Anybody else?
So I agree with you that it's very important to know what problem you're solving, because when we talk about threat analysis, there are lots of different areas that you might want to investigate. The very first thing I think comes in people's minds is really network analysis and network flow and things of that sort. But you can do threat analysis using things like machine learning and artificial intelligence and other ways. I'll give you one specific example. If you have a help desk that has reports coming in mainly natural language, it could be that if you look across all the help desk tickets that are coming on, the natural language complaints, if you like, that you will see a pattern that actually indicates that something more nefarious is going on, not that this is on a user error in Outlook. And again, it's a different kind of problem, but it's a different collection of sensors and you use different kinds of techniques in order to solve that. So again, it's very important to know what problem you're trying to solve and how you're trying to detect it.
Thank you.
Yeah, I totally agree. A lot of times when we see the proposals, everyone wants to put in machine learning and AI and all the cool stuff. But what they don't understand is that it ties to money and time. So when you're looking at solving your problem, you have to not only bound what the problem is, but you have to also bound, can I solve it in time?
Yeah.
And we all know how dynamic cybersecurity is and how dynamic our problems become. So you can go and invest, $3 million into something and it be a 5-year project or whatever, and you're like, the problem has completely changed. So you've got to be very careful as far as,
Phases of delivery.
Exactly.
Okay, so the next question is for me. What are the necessary steps or ingredients as it relates to detection and response? One of the main things that we do with artificial intelligence is behavior analysis, right? Behavior of abnormal and normal behaviors. But one of the several necessary things that are important to us is the type of data that we get and how we do the training, right? That's very important to us. And abnormal and normal behavior, when it is normal, there are various ways of detecting abnormality within the normal behavior. And when we say behavior, we're not really necessarily focused on the human that is interacting with the product. We're looking at the various different types of scenarios, the CSCIs that are talking to each other and how they're interacting. So we really have to step into the product and understand the analysis of the work that the product is doing and the human that is interacting with it and the environment that's interacting with it. So these are all very important for us to really put a good synopsis together that is this a real threat or not. So these are the steps that we take. Anybody else would like to add to that? No, we're good?
I can add.
Yes, sir.
I always have something to say. It might not be important, but it's something to say, right?
We're good, thank you.
So you have the ingredients. I'm looking at it in terms of we have to put sensors in place and you were talking about it.
Yeah.
You alluded to it, but there's data shift and data drift and model drift and things like that. And a lot of times we don't see that the sensors put in place where people are looking at, machine learning is not something you drop in a box and you leave it and you think it's going to grow. And it's not a plant, it's something that you gotta maintain. It's more like a child, like you have to actually, put investment into it to maintain it and sustain it. So and then you have to check it every so often to make sure it's not going off, it's not sneaking out at night, doing anything, kicking a dog, whatever else. But you have to put in the models. It's a model drift, model shift, data drift, and you have to put those elements in place to make sure that you're constantly monitoring and maintaining.
Absolutely. Yes.
Speaking a little bit to the operational side as well, completely agree with both of you. In order to actually have a solution that is going to be used, you need to have something that's reasonable latency for your analysis time, that's properly scalable, because networks by definition are very bursty. During regular working hours, you have much higher throughput. So there's definitely some operational concerns you have to think through. And then if there's some way to introduce user feedback into the training, that way the SOC analysts aren't seeing the same false positives over and over. They need to have ideally some way of introducing their human expertise into the feedback.
Train the agent by the human interaction.
Exactly.
Yeah, that's a very good key element that we can impose onto the AI machine learning. Okay.
So, just
yes,
one more quick comment. Since we're talking about sensors, now's an interesting time to think about how you may want to instrument the various pieces you have. Historically, sensors have operated, I'll use the phrase, in God mode. They have the ability to basically look at anything and do anything. And SolarWinds taught many lessons, and one of them was that if you have something that's operating in that kind of mode, any kind of compromise to the sensor actually can wreak havoc throughout the entire organization. And so as you're trying to collect data from different parts of the organization, and I don't know how many people were here just for the previous presentation on Zero Trust, you'd like to be able to manage what kinds of access and who has the authority to access that. And the same has to be applied to the sensors as well. So when you're putting together your threat analysis and your data analysis, you have to figure out where you're going to get that data from a properly authorized source, and understand that there may be some data that's invisible to you, again, for pretty good reasons, especially if you're thinking in terms of sensitive areas, if you're thinking in terms of financial areas or military areas. You won't be able to get all of it, so how much can you infer from what you can get, and is that enough to do your job? So again, as we move into a more careful environment, I guess it's a good word, you have to think about how you might manage all of that data collection and what you might be able to infer from that.
Excellent. I think we're already stepping into the next set of questions. To be honest with you, we really are. So what are the unique challenges or considerations that you have to do when you're running the AI threat detection? That's a question for Gary.
Right. So some of the unique challenges that I can tell you from the CISA perspective.
Right.
One is people, right? AI, as we're seeing, it has to be maintained, right? So the folks to maintain it, the folks to look at it, it is very hard to get the right people in there, to get the right people trained. If we do get the right people trained, they take that training and they go get twice as 3, 4, 5 times as much money and take that clearance with them. So that's one of the unique challenges with it. The other part is the resources, and not just the people resources, but the hardware type resources to run the AI. And we've had trouble getting that. There's been, you can outsource it, but of course that costs money. And now it brings up the costs to run that, and that's one of the things that we're seeing is that to outsource that to make sure it's manageable, it's sustainable, it has the right answers coming back. You're outsourcing that, and you're taking a chance that you might not be getting the right information back. You'll get information back, but then you'll try to apply it operationally, and it'll be like, what does this mean? I don't know, but that'll be too late. Everything will have already passed. So I think when we look at what are some of our challenges? Our challenges is definitely resources. We need to talk hardware, software, the people aspect, and so we are having a very hard time trying to figure that out.
Gary, there was a hardware person there, I forgot the name specifically, but they focused on the chip design with a massive CPU that can handle. And so you might want to take a look at that. I will catch up with you at the end of this and point you to the vendor that's doing that. They really are taking that because we do have hardware issues, as you pointed out. Okay, anybody else? Yes, sir.
Sure. So actually, BluVector started off as a couple of R&D projects at Northrop, so a great company. But they split us out, and we got bought later by Comcast. But what that means is we've historically had a lot of experience in the federal space, government space. So I know that there's a lot of challenges that come, especially with sensitive networks. Coming up with an air gap solution. So that, there's a lot of operational challenges from a vendor perspective, that we've had to work through for those special networks. One of the capabilities that we developed, called in situ learning, is we try to provide the relearning capabilities on a completely on-prem basis, instead of requiring access to a cloud or some other requirement to send data, because that's definitely a no-go for government agencies. And so what we end up doing is we ship a set of feature vectors that's associated with our training and test set. So when the retraining happens, they can figure out if how much drift there was from the original ground truth of benign versus malicious. It gives more confidence to the analyst to know that they didn't accidentally pollute their training sets or whatnot during the relearning process.
Excellent.
And if you think about what the needs are for the different industries, we have a lot of technology that has, if you like, knobs on it that can vary a whole lot. So to give one extreme example, in the military, they have a command and control structure that says when to fire nuclear missiles. They have a security requirement that absolutely, under no circumstances whatsoever, can a false message be injected in that network and have one of those missiles fire. They're willing to take lots and lots of false positives, but under no circumstances do they want something launched if they don't intend to launch it. On the other hand, if FireEye actually gets a piece of email through to me that I get an ad for the Gap that I shouldn't have gotten, it's probably okay. And so you have to decide what to do. And when you're thinking in terms of AI systems, let me be a little more careful. In terms of machine learning systems, I do believe a distinction exists, although different debate, but I agree. So if you look at machine learning systems, to a first approximation, what you have is a bunch of different data points, pictures of apples and bananas or something, and then you have a function or a line, if you like, that separates all the points that are bananas and all the points that are apples, and you get a new one to say which side of the line is it on. So on one side it's an apple, the other side is called a banana. That's very fine as sort of a first introduction, but as you look in more details as to what that line is realistically, it's not, well, unless you're really, really naive, it's not a straight line. It's got little jaggeds in it and so on as far as what the picture looks like. And it turns out that the way that a lot of these false examples that you read about, like stop signs that look like pigeons or what have you, many times what they do is they're in one of those little sort of peaks that go up or one of those little indentations in that function is they basically have a point that fits right in there, and they basically craft it so it can fit right in there. And so you can force this to mislabel some things that are going on. But there's math here that says, well, there's ways I can smooth out those points and everything else. I trade off between false positives and false negatives by doing those kinds of techniques. And so it comes down to, as a policy decision, which things are more important for you to recognize, because the math is there, we know there's a trade-off. It's not a perfect case that I can increase both simultaneously. And so is it more important to make sure that nothing bad ever gets through and I'm willing to live with a lot of false positives, or I really don't want to be bothered a whole lot unless I'm really, really sure that I need to be bothered, in which case you want to let false negatives go. So again, since we're talking about industry-specific things, it has to do with what your tolerance for risk is in the different kinds of scenarios that come out, and you can actually tweak the machine learning systems in order to meet those kinds of policies.
So Mark, would you say that what you just described is the most difficult thing as it relates to our environment, or is there like top condition that you consider the most difficult?
So I think the most difficult has already been identified as having labeled data. Having examples of what's there and what's not there is exceedingly difficult to have. And as I said, the next biggest problem, again, you alluded to it as well, is something called the imbalanced set or imbalanced classification. It goes by different names. But again, as far as the math is concerned, if you have only few examples of something that you're trying to detect, and say you're trying to tell cats from dogs, you have 1 million pictures of cats and 100 pictures of dogs, the system will not perform very well because it has so few dogs in it. Now, there's a whole set of statistical mathematics that says, what should you do about that? Again, going to the comments that you made earlier, by which you can synthetically create more dogs so that the classification system will work better. But there are many different ways of doing that. Each one has its positives and its negatives. But that's another challenge, because most of the time, the anomalies you're looking for are rare events. That most of the time, my machine isn't being attacked. Most of the email I get is not virus email.
Right. So training on anomalies and the problems that you face every day. Okay. Yes, sir?
Yeah, from an operational standpoint, definitely you did a great job describing the false positive, false negative trade-off. But as you said, there's a ton of events that you're going to see, and even if you have a 0.1% false positive rate on an extremely common event, that's going to overwhelm your SOC team. So anything you can do to drive down false positives to actually increase adoption. And then the other big problem that we've noticed, just trying to sell out to the marketplace is, trying to get trust in the model. So how do you actually explain what decision made? Because a lot of ML is just being a black box, and even if you could tell the features, sometimes they might not be human readable. So I mean that's definitely something that's difficult. But what you can try to do is provide additional context around that, and then there's just a general, as they continue to use it, and they start to see value out of it, it's sort of an earned trust capability.
Okay, excellent. So Mark, what do you see in the future? Where do you see us? What the threat looks like? What does AI look like? And how these two play well together? What is coming up?
I think what we're going to see is a continuing cat and mouse kind of situation or war, depending on how you like to look at it. That as we use machine learning kinds of techniques in order to find problems, if you like, the bad guys are doing the same thing. And more to the point, there are well-known techniques for extracting what models look like in these kinds of systems. And so a bad guy, if they know that FireEye is the common target they want to go after, just to pick an example, can work to extract the model out of FireEye and come up with the examples that will in fact defeat it. And to give you a very concrete example of that, and I hope I'm not going to offend any vendor here, one of the tasks we were asked to do by one of the agencies that we support was to take a look at a collection of firewalls that said they use AI in order to protect themselves. And the question we're asking is, so how much of this is marketing hype and how much of it is something real? And again, using these techniques, they're all written about in the textbooks. There's nothing really that you have to invent here from scratch. But we were able to extract the models out of every single one of them and come up with cases that would defeat every single one of them. And so the future is having to deal with the fact that both sides are evolving. And we know
They're getting smarter and smarter and
they
smarter.
are, and we know that they know what we know. And I say that from personal experience as a quasi-academic. When I publish papers, they get registered in various kinds of venues that track professors' output, things of that sort. And I get a weekly report of, so how many people have downloaded your paper and who have read it, where they come from. I see that my papers are being downloaded and read in China and Russia and Iran. So you know that.
Yeah, you kind of know that they're catching up and we're like it's a cat and mouse game. Absolutely. Okay, and the last question, and this is for Ryan. So when you're building the infrastructure of your environment, you have to do a lot of interaction and there are a lot of stakeholders that kind of gonna have to work together. What are the difficulties and the challenges as these relationships have to be built?
Sure. So when we're talking with a lot of potential clients or just particularly large companies, since those are the ones that we focus on, it's always a big debate as to whether you want to build versus buy. There's definitely a lot of work that's required to operationalize, and Gary mentioned that it could take years to develop a solution, at which point it'd be out of date versus there might be something off the shelf that you can at least buy or partner with to kickstart your development effort. So typically those long development cycles, the high cost to build the initial solution, but then also maintain it and keep it updated and so on and so forth. If you do decide to build something, then partnering with those groups that have those expertise, looking for more open platforms so you can integrate your existing analytics. I think partnering with red team groups that do red team exercises is really critical.
Early
Exactly, early on in the development process. Or if you're purchasing something to either evaluating it or your existing security stack, at least you can identify those those gaps early on and start thinking about it and addressing it. And constantly have those red team exercises ongoing as you continue your iterative development.
If I can add to that one of the difficulties that the partnership with your customer and the trust and the build that you have to build with our customer, which is, in our case, it's the Department of Defense. Having that relationship, having that trust in the design is critical. And phasing and looping them in constantly and having their feedback as how it works really gets their buy-in at the same time and also allows us to execute a better product. Those are the challenges that we have to make sure that we're in sync with them, they understand the product, and we understand their requirements and the environment. Any other comments?
Sure.
Go ahead.
I was just going to mention, so one of the things that I think ties to this point is the vendor lock-in issue. And, we've seen it on other, especially in the government sector, we've seen it on other aspects of what we deal with. And I'm hopeful in the future that we have less and less of that because we have more interoperability. I think that's going to be very instrumental in the advancement of AI because it's I think that hopefully there's some Cisco people here, but everybody remembers with Cisco, for a while they didn't operate with it didn't play nicely with other vendors, and we see that sometimes in the ICS world, right? There's a hard line where folks don't want to cross because there's who broke it, who's to blame? So we got to really try to work that issue as far as those partnerships to make sure that we are getting a good product together that can interoperate with many different elements.
Absolutely. Any other comments?
So I just want to offer one more thought, which is really not specific to machine learning, but is one of the challenges we have in trying to support better threat identification and analysis. It's sort of what I call the dual use issue. How many people here have heard of Pegasus, for example? Okay, so for those who don't know, there's a company in Israel that built a piece of software called Pegasus that you can put on cell phones and basically surreptitiously take over your cell phone and listen to things. Now, the official story from Pegasus is it's used in order to help governments fight terrorism and law enforcement issues and things of that sort. But obviously, you can use it for other things as well. And there are lots of these kinds of detection technologies that have these dual uses and where you can think for legitimate reasons. But then the government may not want to have some of those things be exposed as well because then you might use them for illegitimate reasons. And so as we come up with ways to detect threats and to get around those detections, we have a sort of societal policy issue as to when we can employ them and when we shouldn't employ them. And as the technologist, I sort of work on the tools, but I'm sensitive to the fact that we need to worry about how they're going to be used as well and make policymakers aware of what they are getting when they get the technology so we can make the
Policy versus technology. Yeah. Okay, I love this part of it, where you guys get to ask us questions, become more interactive, and we're available. We have another, I'd say, 20 minutes. So please ask us the questions. Yes, sir, in the back?
Yes. So the question is posed on BluVector. How do you avoid the silos of the internet outcomes from different device introduced phone data, computer data, product policy data? How do you bring all those together for AI? And your usage for including content and maybe this diesel, I heard of that, citation, Comcast, how do you integrate those together? Good data points from AI support the
Right.
So something that we didn't really get into, but it's also part of how the machine learning systems are built, is doing feature engineering and then principal component analysis. And it's a big challenge because I don't think it's an exaggeration for some of the models I've seen that you may have well over 1,000 different features, and you can't really build these systems to all look at 1,000 features. And so the feature engineering is to somehow collect those into meaningful ways. And then again, the technical term is principal component analysis to figure out which of those matter. And that can be done within one particular set of sensors or across multiple sets of sensors. And it's, I don't want to say it's magic, but it's a lot of work in order to do that. And you're better data scientists who are trained, and again, not intending to disparage anyone, I'm not talking about the people who download the open source machine learning systems and then sort of know how to train it once, but people who have really studied the math spend a lot of time building these systems on this feature engineering aspect of it. In fact, they spend more time on feature engineering and data cleansing than they actually do building the models. And that's because it's so tricky to get those kinds of things right. A bigger problem that I think we have observed is not the technology, but the organizational will to allow different pieces of the organization who are collecting the different pieces of data sharing between other organizations. that there's a lot of resistance or fear of how their data might be misused. In some cases,
You can't take site configuration data and bring it out, and they're not gonna allow, certainly not in DoD.
so that's, that in some sense, I think is more the challenge than the actual technical challenge.
And
Yeah.
I agree with that feature engineering portion of it, sorry about that. I've done a few machine learning problems where it took me more time to actually figure out which features really make a difference, right? And we're talking about, you're getting all these data streams in, but you're not all of them really impact your solution, right? Or not impact it or move it heavily. So you have to work on that, and I think that's where he's talking about. You have to be able to set it up so that it's almost like, if you guys are familiar with operations research, it's almost like a sensitivity analysis of, is this feature more important than this feature, and will it move my solution closer to what I think is, and that's just more leaning towards the supervised learning. But then you get to the unsupervised learning part of it, and then things really become even more hectic. So that's really where we're looking at.
Sorry, definitely echo the feature engineering and the data inputs. Even if you have the policies in place to allow for that, just putting in place operationally the plumbing to actually get it to a centralized place. I mean, really large, corporations might have these massive data lakes. Sometimes they don't. Particularly once you get into middle-sized and smaller companies, they just don't have the expertise, or they don't have any centralization of the data, and so half the challenge is just seeing the data in order to make an analysis, rigorous analysis with your engine.
Okay, excellent. So data clustering, feature selection, data cleansing. Okay. All right, any kind of questions? Yes, sir.
Well, personally, I'm a cybersecurity engineer, they kind of dabble in machine learning. And so my big concern comes a lot from the standpoint, when we take machine learning and we put it into a inherently necessary environment, cybersecurity, what kind of measures should we take or should we take to ensure that our machine learning, the one we can detect when it's being attacked, especially when it's so local scale attack, and then how do you recover from that? I always talk about it's my Uncle Ron's problem. Because when my son was little, whenever he goes to my Uncle Ron, I said, don't learn anything new. When he comes home, I quiz it to see if he learned anything new.
True.
So I'm going to have to retrain him. How do I know when Uncle Ron has taught my machine learning algorithm something?
Yeah, I think okay, go ahead.
So I don't know that I have a very satisfying answer for you, because we've done a fair amount of work of how one secures machine learning systems. Forget about whether they're using cybersecurity or not, just generically, how you secure a machine learning based system. The attack surface is quite vast, starting all the way from the data, how it's separated into test data versus training data, how the features are combined into principal component analysis, whether you attack the algorithm that's used to build the model, whether you attack the algorithm that does the decision point, when it does the gradient set in order to take the errors. You can inject attacks at any part of that process. Then you add in things like active learning, which is one of the techniques that people didn't label here, but you've heard people talk about that the model has to evolve as the data in the environment evolves. Again, one of the more common techniques is something called active learning, where the model is constantly being tweaked. There's I'm trying to remember to get the exact word, the boiling frog attack, in where you slowly move it. And eventually you wind up with something that doesn't make any sense. I'm not really aware of a comprehensive answer to your question, other than sort of classical kinds of things to do, which are have redundant systems. And so if they start to diverge from each other, then to flag that something unusual is happening and cause for investigation. But it's not really as satisfying an answer as you're probably looking for. Maybe others have some better answers.
Yeah, there's no really good one-size-fits-all solution there. In the case of our in-situ learning, we try to, as I said, give some sort of baseline as to our definitions of good and bad in the lab, and you can look for the drift from there as some sort of indicator, but it's one that's basically
what it is. I mean, there's no definitive answer for it, but that's where I was talking earlier about the model drift, the data drift. You have to look for that. There are folks that are working on data poisoning, looking at how you can get these are, and this is why I always say before you get into machine learning and AI, don't believe the hype. It's a lot of work, right? You're going to constantly be doing stuff that you're like, oh my gosh, this is I equated truly having kids because I'm like, whoa, we got to pay for college, we got to pay for soccer, we got to pay for this. All this didn't come with me, it's like, but it's all the hidden costs that you didn't see, and that's where you've got to really prepare for that. But the way to answer your question is basically maintain, and check.
Yes. We got a couple of more minutes. Any questions?
Yes, so if all the backups get access to the latest ingredient,
That's it.
So the public, that's his fault. The public
He's
stuff.
publishing stuff, that's his fault.
He's the backup.
The public stuff, let's say it that way.
how we kept ahead of the game? Is it because we have better hardware?
Because
I believe what we do is we learn from each other. One of the things that we do at Northrop Grumman is actually utilize the research community, the top tier universities that impose new designs and new algorithms. And one of my job is actually taking those initiatives into the program of records. So we funnel new energy into our environment. And Department of Defense actually demands for us to have that kind of knowledge transfer throughout our industry. And we are at the front with the customer, kind of bringing and imposing those designs to the customer and take their buy-ins. Anybody else?
I mean, from a vendor perspective, we're always trying to break our own stuff. Either with internal teams or external red teams. So,
there's a whole variety of things that are going on. So the direct answer to your question from my perspective is basically investment priority. If you can get really bright kids to go into this kind of work instead of going into Wall Street, you have a better chance of doing that. But let's be honest. If you've got a billion population, the top 1% of that population is probably a lot more smart geniuses than the 1% of a 300 billion population. And so the question is, how do they get deployed? They've got great universities there. We've got great universities here. They've got dark places that they do work. We have dark places that we do work. And so, it's how important is it to you, and what is your priority, and what are you trying to get accomplished? But as you mentioned, that's just in the threat detection kinds of techniques that we're talking about here. One can make any adversary have a more expensive price to pay through smart architecture and smart development. And at least in my experience, I'll say one sentence then, the lack of cyber hygiene across industries, government and private sector, is far more the issue than the clever algorithms that I come up with or my adversaries over in the other countries come up with. If we do more of that, we'd be a whole lot safer.
Partnerships with industry, academia, and government. Those are what really help us to get ahead. And if we work those more, we'll definitely get ahead.
Excellent. Thank you very much, everyone. We're at the end of our time. It was our pleasure to speak to you.